students, here we have a third order differential equation. For this differential equation, this cubic equation is the auxiliary equation. Now solving it, we get d into d square plus 1 is equal to 0, which gives d is equal to 0 or d is equal to plus minus iota. Here we have three roots, so the complementary function yc is equal to c1 e power 0x plus c2 cos x plus c3. By using variation of parameters, variation of parameter is also called variation of constant. So replace c1, c2, c3 by function a, b, c. Here a, b, c are the three function of x. Now yp can also be written as a into y1 plus b into y2 plus c into y3. Here this y1 is equal to 1, this y2 is equal to cos x, this y3 is equal to sin x. y1, y2, y3, all of them have been written here. Now in this slide we see equation 1, which is the complementary function. We see equation 2, which is the particular integral. The complete solution will be equal to y is equal to yc plus yp. Now to find value of yp, we have to find value of a, b and c. Before finding value of a, b, c, we have to find the Ruskin of the solutions y1, y2, y3. Now the values of Ruskin, writing all the solutions y1, y2, y3 as a determinant. So the first row will have the solutions, the second row will have its first order derivative, the third row will have its second order derivative. Now putting the values, y1 is equal to 1, y2 is equal to cos x, y3 is equal to sin x. All these values are here. Now derivative of first row is equal to this one, derivative of this row is equal to this one. Now expanding by c1, which is equal to determinant of minus sin x cos x minus cos x sin x minus sin x. Now evaluate the value of this determinant. This product will be taken as positive, this product will be taken as negative. This plus is on account of this minus and the minus in the formula. Now sin square plus cos square is equal to 1, which is not equal to 0. Here value of Ruskin is equal to 1. Function A formula for function B, and similarly for C. Here we will take s over w, here we will take minus s over w, here we will do log of secant x. So to find value of A, we have to take integral, we have to take s over w, and we have to write the determinant by ignoring y1 which belong to A, and we will write other two solutions y2 and y3. Similarly, to find value of B, we will remember to put here the negative sign, and we will ignore the solution y2 which belong to B, and we will write the other two solutions which are y1, y3, and here we will have its derivative. Now putting the value s is equal to tangent x, which is the right hand side function in the differential equation. This w is equal to 1, which is the value of Ruskin, and value of y1 is 1, value of y3 is equal to sine, derivative of this row is equal to this one. Now finding value of the determinant, here we will have cos x minus 0. So this is cos x and integral minus tangent. Now this tangent is sine over cos, cancelling cos, we get integral minus sine, which is equal to cos x. Integral of minus sine is equal to cos x, hence value of b is equal to cos x. So value of a is equal to this one, value of b is equal to this one. Now we have to find value of c. So we will always put integral sign, and s over w we will ignore the third solution y3, and we will write the remaining two solution here, and we will write their derivatives here. Now by putting the value, now this integral tangent will be here, and finding value of the determinant, here we will have minus sine x minus 0. Now writing tangent is sine over cos. So here we have 2 sine, 1 sine here, another sine here. The 2 sine will be sine square divided by cos x. Now this sine square is equal to 1 minus cos square. Now simplifying, we get 1 over cos into cos square divided by cos. 1 over cos is secant, and here we will have integral cos. Integral of secant is equal to log of secant plus tangent. Integral of cos is always sin x. Now taking this negative sign within the bracket, so this will be the value. This is value of c. Here we found the value of function a, b and c. Now we have to, from 2 we will pick up yp again. Now we will put value of a, b, c. So value of a is equal to this one. Similarly value of b is equal to cos x, and this y2 is it is. Similarly value of c is equal to this one, and this y3 is again here. Now we will put y2. This y2 is equal to cos x. This is y2 which is here. Now this is y3 whose value is here. Now cos into cos is equal to cos square. Sine into sine is equal to sine square. This sine into this one is this one. Now cos square plus sine square is equal to 1. So yp is equal to log of secant plus 1. From here value of this sum is equal to 1, and this term will be here. This is the required particular integral. Now we know that y is equal to yc plus yp. So here these three terms represent yc, and the last value represent yp. Now taking c1, this c1 e power 0 x equal to c1, and this 1 will be written here. Now here we have two constant which is represented by c4, and the remaining relation will be written as it is. So this is the complete solution of the third order differential equation. Solve the differential equation by variation of parameters. Variation of parameter is also called variation of constant. Here we have third order differential equation. We can write in the operator form as d cube minus d into y is equal to x. From this equation, homogeneous differential equation is d cube minus d into y is equal to 0, and from this equation the auxiliary equation or characteristic equation is this one. This is the auxiliary equation which can be written as d into d square minus 1 is equal to 0. Now d square minus 1 is d minus 1 d plus 1. Here we have three factors. By 0 product property, either d is 0 or d minus 1 is 0, which gives d is equal to 1. Similarly, either d plus 1 will be 0, which gives d is equal to minus 1. Here we have three roots, and from these three roots we can write complementary function as this one. This is the complementary function, and which is equal to this one. Now we have to use variation of parameters, so we will replace c1, c2, c3 by three functions. These a, b, c are function of x. Now this is a, and here we have 1, so a y1. This is b, which is here. This function is represented by y2. This is a solution represented by y2. This function is again here. This solution will be represented by y3. Hence y1, y2, y3 are shown here. Now the Raskian of y1, y2, y3 is given by, this is Raskian, putting the values, expanding by c1. This is the second order determinant, finding value. This product will be positive, this product will be negative. E power x into e power minus x, adding exponent. Similarly, multiplying this diagonal. we will get plus e power minus x plus x, which is e power 0, which is 1. Similarly, e power 0, which is 1. And finally we get 2, which is not equal to 0, hence the value of Raskin is equal to 2. Now we know 3 formulas. This is the formula which has already been used, though. Now putting the value and simplifying, this will be positive product, this will be negative product. Now e power 0, here we have e power 0, which is 1, so here we will have minus 1. Similarly, here we will have minus 1, minus 1, minus 1 is equal to minus 2. These two will be cancelled. We get minus integral x, which is equal to minus x squared by 2. Hence value of a is this one. Now if here is plus par a, we will use plus, par b we will use minus sign. We will write the solution y1, y3, and we will ignore y2, which belong to b. Now putting the values, now this product will be positive, this product will be negative. So here we will have minus e power minus x. Now minus into minus is equal to plus. This 1 over 2 will be here. Now here we will use the integration by parts. This is first function, this is second. So first function integral of this second, which is this one. Now the derivative of x is equal to 1, and this integration will be here again. Now minus into minus is equal to plus, and integral of e power minus x is equal to minus e power minus x. So this is value of b. Now this is value of b. Now we know value of c, which is always written in this way. Now putting the value, this product will be positive, this product will be negative, so we get e power x, and this will be 0. Now this 1 over 2 will be here. Here we have two functions, so by using integration by parts, which is equal to this one, hence value of c is this one. Now from equation 2, this is the particular integral. Now putting value of a, b, and c. So this is value of a. Similarly, this e power x is again here. This is e power x. This is e power x, and this one is this is the value of b. Similarly, this is e power minus x, and this is value of c. Now this term will be here. This e power x will go inside, so this and this will be equal to e power 0, and e power 0 to 1, so we get minus x here. Product of these two will be e power 0, which is equal to 1, so here we will have minus 1. And similarly, this is 1 over 2, e power x into e power minus x is equal to e power 0, which is equal to 1, and this product of these two will be 1. Now this is minus here, this term will be cancelled with this term. This minus 1 over 2, here we have 1 over 2 into minus 1, minus 1 over 2. Similarly, here we have minus 1 over 2, minus 1 over 2, minus 1 over 2 is equal to minus 1, and this x minus x squared over 2 will be here. So this is yp. Now the complete solution is y is equal to yc plus yp. These three terms are par yc, and these two are par yp. Now this is c1, this is minus 1. This c1 is a constant, and similarly minus 1 is a constant. So we will replace these two constants by c4, and the remaining, this term will be here again, this term will be here again, this term will be here again. So this is the complete solution of the third order differential equation. Thank you.